Okay, so matter. We're talking about matter all the way back from the beginning. Matter, it takes up space and it has weight. What is it called if it takes up space?
Volume.
Thank you, volume. This is very important that you know these key vocabulary words. What is another word for weight? So anytime you see mass, you know we're talking about weight, and anytime you're talking about the space it's taken up, you know we're talking about volume. Now, these are all physical properties. These are ways that you can describe something. It's their physical property trait. You can talk about what it looks like, what color it is, how much it weighs, how much space it's taken up, what it feels like. It's using your senses to measure or to describe the physical property of anything. You need to know that if you're talking about weight, what do you use to measure weight?
Scale.
Scale, thank you. What do you need to measure the volume of something? The graduated cylinder, or if it's a perfect square, you could do length times width times height, a meter stick or something. But graduated cylinder, how do we measure volume?
Wait, I know. Wait.
Ooh, length. How do we measure the volume? How do we measure how much space something is taking up? Right, you put it in water. The water goes from here, you put it in the water, and it moves to here. This space that it took up to push the water out of the way is the volume of something. And we can tell by the texture, by the way it feels. We can tell by our eyes what color it is. We can tell the temperature by its thermometer, using a thermometer. All right, well, when we're talking about physical properties, we're talking about the physical state of matter it's in. Solids, liquids, and gases. You should know that a solid, they don't move. They sit there. They are set. That shape is the same shape no matter where you put it. So it will always have a definite shape, always have a definite volume. Okay? If I have a Rubik's Cube, it's that same shape here, underwater, outer space, in the back seat, wherever. When you get to liquids, liquids are moving around a little bit. That's why it takes a definite shape, or the shape is whatever shape the container it's in. So if it's a bendy straw, it's a bendy shape. Okay, but the volume will stay the same. The mass will stay the same. Finally is the gas. The gas is the one where they're all bouncing around. They take up the shape and volume of whatever container it's in. If it's a water bottle, if it's in a classroom, if it's in an auditorium, it's that shape of all of the gas. Mixtures, which is the next page. When it came to mixtures, this is a combination of any two or more items. I can mix peanuts and raisins and Cracker Jacks, and I got a mixture of snack mix or whatever. In 4th grade, you learned how we could separate it. We could separate it by the color, by their shape. You even learned of a crazy one by using a magnet over some of them. But in 5th grade, we're adding a few to it. We talked about sieving or sieving. This is taking a strainer, separating it through little tiny holes. The bigger solids will get separate from the littler solids. We talked about filtration or a filter. This is separating solids from the liquids, like coffee grounds will separate from the coffee liquid. Okay? And then the one that most of you guys got confused on was flotation and sedimentation. Flotation means it is floating. So a lot of you kept putting, oh, it's when you separate things and things go to the bottom of the water. Does that mean floating is at the bottom of the water? No. That is sedimentation. Sedimentation is when it sinks to the bottom. Sink, sediment, S. Flotation is on the top. Okay? We then moved to last week. I'm sorry, we talked about dissolving. How do we dissolve things? Dissolving is when we put something in a liquid and it disappears. It mixes up so well that it disappears. And in our lab, we learned that things like sugar will disappear when you mix it in water. What else?
Cinnamon.
Salt did, right? Did cinnamon disappear?
No.
No, you can see all the little specks of cinnamon still in there. Did sand disappear?
No.
No, what would happen if sand disappeared? What? Say it, Mason. You wouldn't have any sand at the beach. There would be no sand left. Every time it rained, sand would be gone, right?
Yeah.
So sand cannot dissolve. How did we learn to dissolve things faster? There was 3 things we can do. Okay, heat. Okay, stir it up, heat it up, or huh? Oh, I can't hear you real loud. I still can't hear you. Yes, sir. Break it up. Small, make it smaller, right? So stir it up, break it up, heat it up. It'll make things dissolve faster. And then last week we got into changes. A physical versus chemical change. It is a basic checklist, okay? Physical change means you're changing from one thing to the other, but it's still made of the same stuff. It was water, it turns to ice. It was made out of water, it's still made out of water, okay? The biggest thing when it came to physical changes was that physical property of solids, liquids, and gases going from a solid to a liquid, liquid to a gas, and back, okay? You have to know that if you heat up a solid and it turns into a liquid, it's called, oh my goodness, ready? Let's try it again since we're not listening and paying attention. It went from a solid, I heated up a solid to a liquid. What is that called?
Melting.
Thank you. What happens if I cool it down and it goes from a liquid to a solid? Freezing. What is it called if I go from a hot steam gas and I cool it down to a liquid? Condensation. What would happen if I took that water and I got it even hotter and it turned into a gas? Or depends on how fast. Okay? This is very important. This is just a physical change. It's going from water to water to water to water to water. We're just changing the state. The one that threw a lot of you was when we got to chemical changes. A chemical change is one of 3 things, and basically it's changing from something to something completely different. Chemical changes are the magic ones. Okay? And how did we come up with figuring out whether it was a chemical change or not? It was 3 things. This should be your checklist. You go, did it do this? Did it do this? Did it do this? If you say yes to any one of those 3, you're done. It's a chemical change. If you say no, 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 then it's a physical change. What were the 3 things that determines whether it was a chemical change or not? Did it, what? Color. Did it change color? I don't care if it changes color. If it goes from silver to brown, if it goes from green to orange, if it changes color, it's a chemical change. What else? Heat. If it changes temperature. If I burn it, if I stick it in the fire and it burns, or I stick it in the oven and it burns or heats up, that's a chemical change. And finally, if it makes any kind of bubbles, foam, fizzing, anything with gas, it is a chemical change. So we did a whole lab last week, and it should have been an easy, did it change color? Did it change temperature? Did it make a gas? If you say yes to any one of those, it was a chemical change. If you say no, then it was a physical change. Okay? Water to an ice cube, did it change color?
No.
Water's clear, ice cubes are clear. Did it change temperature
Yes, but
on its own? No, I made it get colder. Did it make any bubbles when it was freezing?
No.
Then that's a physical change. Okay? Any questions for what's on your test tomorrow? It's all these from the last 3 weeks. If you know this information, applying it to the scenarios, you'll do fine.